Hey physics, so today we're doing a gizmo and I wanted to show you kind of how to do it. If you don't want to use this video, that's totally fine, but this is a good way, like if you feel like you might struggle with this is a good thing that you can follow along with. The answers will be in here. I feel like if you take the time to watch this, it's just as good as figuring it out yourself. And if you want that challenge of figuring it out yourself, you should do that, but I would rather have you watch this and not struggle than, struggle through it and then get a bunch of answers wrong. You know what I mean? So, okay, so explorelearning.com, and then you're going to go to my classes, you're going to log in. You should have a thing already there. If you switched classes over this semester, then it's still fine. You can just use your old class. Go into your classes and find distance time graphs metric, and then you're going to say launch gizmo. And when you say that, you are going to get a screen that looks a lot like this, and you're going to open up your distance time graphs gizmo worksheet that looks like this. Start off with the prior knowledge questions. Who ran faster, Max? Oh, who ran farther, Max or Molly? So we have Max ran 50 meters in 10 seconds versus, sorry, we had an announcement over the intercom. So who ran farther, Max or Molly? Well, Max ran 50 meters compared to Molly's 30 meters. So Max ran farther. But who ran faster? In order to do that, I would like to write it out. So this is Max over here, and this is Molly over here. So what I need to do here to find out whose meters per seconds were greater is to just divide this. So 50 divided by 10 is going to be 5. 30 divided by 5 is going to be 6, right? Because 5 times 6 is 30. So Molly is actually faster here. Okay? Because 30 meters in 5 seconds is 6 meters per second versus Max's 5 meters per second. Okay. So check the number. So we're going to, the distance time graphs gizmo shows a graph and a runner on a track. You can control the motion of the runner by manipulating the graph and dragging the red dots. So check that the number of points is 2, and that the under runner 1 both show graph and show animation are turned on. So give me just a second to do that. So number of points is 2, okay. And under runner 1, show graph and show animation. Okay, runner 1, show graph, show animation. Okay, got it. So click the green start button. Okay, let's watch what happens here. Green. Okay, so it took them 4 seconds to run 40 meters. And generally, if the number is less than 12, you should write it out in letters instead of numbers, just so you know. Not a big deal. Click the red reset button. What's going on? Hold on a second. Okay, so the next question. So there's this vertical green probe. It looks like this. This is the probe that they're talking about. And it lets you know, you can kind of like pinpoint a spot with this. So what it asks is, what is the position of the runner at 1 second? Sorry, oh, there I am. Weird. At 1 second, the runner has run 10 meters, okay? And we can tell that because we can see 1 second and 10 meters there. On the 30-meter line, when was the runner on the 30-meter line? At 3 seconds. So there's 30 meters right there, and there's 3 seconds. So 3 seconds, 30 meters. Okay, let me just write that down. Okay, so now we're on to activity A. And the first question here is, if a distance time graph contains the point 4, 15, what does that tell you about the runner? So I came over here and I did that, and so in this case, if we kept it just like this, that would mean that the runner had run 15 meters from the starting line in 4 seconds. But that's also true if it looks like this, right? But the difference here is that is that maybe they started farther away from the starting line, but they still ended up at 4 seconds. They were 15 meters away from the starting line. So that's what that means. So the next question is, look at the graph to the right. Notice where the green probe is. If you could see the runner and the stopwatch at this moment, what would you see? So I actually came over here and did this on mine too. I made my line look just like theirs, starting him at 22 meters from the starting line and ending up at 15 meters from the starting line. And here at 1.5 seconds, he is 20.5 meters away from the starting line. Okay? And I think the other thing to note here is that the fact that this is slanted down means that the runner is getting closer to the starting line as he goes, and that's why you can see down here he's actually facing that way. So he's getting closer to the starting line, and after 1.5 seconds he's at 20.5 meters from the starting line. So then number 3, look at the image below from the gizmo. What must be true about this runner's graph? So if we're charting time on the x-axis as the independent variable and distance on the y-axis as the dependent variable, then it looks like at 3.25 seconds, the runner is at 25 meters. And we can tll, because we can see the difference of that slope there, that he's going away from the finish line. He's going farther away from the finish line. Okay? I said that backwards. He's going farther away from the starting line, because that's what that graph is about. Okay, so I wrote at 3.25 seconds, the runner is 25 meters away from the starting line and moving away from the starting line, which is how we can tell because the graph slopes upward as the distance increases. So now we're going to look at the point on the graph that lies on the y-axis, called the y-intercept. So the y-intercept is the spot where the line hits the y-axis, okay? So what does the y-intercept tell you about the runner? So the y-intercept, let's look at this. The y-intercept tells you how far away from the starting line the runner starts, okay? So if he starts here, he's starting at the starting line at 0. And if he's starting over here, he's starting 40 meters from the starting line, okay? So how far the runner starts from the starting line. Okay, so this next question says, in the gizmo, set the number of points to 3. Then create a graph of a runner who starts at the 20-meter line, runs to the 40-meter line, and finishes at the 30-meter line. Okay, so setting my number of points to 3. Okay, so this runner starts at, wait, I guess I need to hit reset. Okay, now we got 3. Starts at 20, goes to 40, and ends up at 30. So that's what that graph is going to look like. Distance versus time, okay? Okay, we're not going to worry about sketching that because you can see what's there. So what is the y-intercept of your graph? So the place where that line intercepts the y-axis is 20 meters. See, 20 meters. Okay, activity B. Here we go. So hit the red reset button right there. Click. Okay. So create a graph of a runner that is running forward from left to right in the gizmo. So sketch your graph to the right. If the runner is moving from left to right in the gizmo, how does the graph always look? So we know about this already. If he's running from left to right, then that graph is going to go upwards like this. He's getting farther away from the starting line. So if the runner is moving from left to right, the graph will have a positive slope because he's moving away from the starting line, like so. Next question. Create a graph of a runner that is running from right to left. Sketch it to the right. Okay, so we're going to reset this. So if he's starting on the right side, that means that the graph is going to start up here, and if he's going right to left, he's going to be going closer to the starting line. So it's going to have a negative slope, okay? Okay, so now we're going to change the number of points to 5. We're going to create a graph of a runner that runs left to right for 1 second, rests for 2 seconds, and then continues running in the same direction. Okay, so changing number of points to 5. So runs left to right for 1 second, so we'll go ahead and start him at 0. Left to right for 1 second, rests for 2 seconds, and then continues running in the same direction. Okay, so there's 1 second of rest, 2 seconds of rest. Oops, and then I moved myself. And then he's going to keep moving. I could have made the slope whatever I wanted to on these moving parts, but the important part there is that when he's resting, then there's no movement. Like, he's not going anywhere. So the time is passing, but the distance is not changing. Okay? So the graph shows a runner at rest when the time is passing, x-axis, but the y-axis is not changing. X-axis staying the same, y-axis not changing. Okay? In general, how does a distance time graph show you which direction the runner is moving? So if they're moving closer to the start, then it's going to be, if they're starting far away, moving closer, it's going to be a negative slope. If they're starting close and moving farther away, there's going to be a positive slope. So going farther away, the graph goes up. So the question is, how does a distance time graph show you which direction the runner is moving? If the runner is moving farther away, the graph will have a positive slope, go up, as we can see here, running farther away from the starting line. But if the graph goes downwards, that means that they're starting farther away and getting closer. Okay, distance is going down. Closer. Okay, so now we're breaking this down. So we got number of points set to 3. We're going to create this graph. So it's got the points 0, 0, 2, 10, and 440, meaning seconds and meters of distance. So mine looks just like that. So now we're going to answer some questions about it. Where does the runner start? At the starting line, which is 0 meters. Where will he be after 2 seconds? So there's 2 seconds, so at 10 meters, or like 10 meters away. And after 4 seconds, he is 40 meters away. Okay, in which time interval do you think the runner will be moving most quickly? Okay, so now we're looking at the slope of this line here. And I see it took him 2 seconds to get to 10 meters. But then it only took 2 seconds more for him to get to 40 meters. So I'm going to say 2 to 4 seconds is when he moved most quickly. Okay, so click the start button and watch the animation. What about the runner changed after 2 seconds of running? So let's look at this. Let me move myself so you can see it. Play. Run, 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 run. Run, 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 fast. Okay, so kind of fast, really fast. Okay, so after 2 seconds, the runner sped up. So now we're going to calculate speed, and the way we're going to do that is by dividing the meters, it's going to be meters divided by seconds. So in the first 2 seconds, how far did the runner go? So 2 seconds, so it's going to be 10 meters divided by 2 seconds. So he went 5 meters per second, and you can see that that is true because there's 5 meters per second right there. Okay. Okay, so the first 2 seconds, the runner went 10 meters, which is 5 meters per second because it's 10 meters divided by 2 seconds. So that's the runner's speed, is 5 meters per second. So now we're going to look at the last 2 seconds. How far did the runner go? So the runner went 30 meters in 2 seconds. So 30 meters in 2 seconds. How far did the runner go each second? So that's going to be 15 meters per second, and that's also his speed. Okay, click the reset button. How can you estimate the speed of the runner by looking at a graph? So you're going to take the number of meters divided by the number of seconds. That's how you get the speed. Cool? Thanks for watching. I hope this was helpful. We'll do Activity C in class together. See you guys later. Bye.